All right, so there are only 2 people I don't know personally in the audience. Can I ask you what your name is?
My name is Adam.
And you're interested in asset monitoring?
No, really.
In the area or?
I'm just here to support,
Okay.
more or less.
Can I ask you?
I'm Ed Shadowski from Emerson.
Amazon, okay. Okay, so my name is Sasha Sheik. I'm the engineering manager for erosion monitoring and condition monitoring solutions at Untitled 2. And the title of this presentation is Rethink Asset Monitoring. And you might wonder why rethink. And you maybe have seen our banners about Think IIoT 2.0. So I want to highlight again what the difference is between IIoT 1.0 and IIoT 2.0. IIoT 1.0 was very heavily focused on the technology and the infrastructure for the digital transformation. Using the initial concepts as big data, for example, digital twin, AI. However, there were studies showing that the majority of those projects in industrial companies never made it beyond the proof of concept phase. Only maybe 25% of all projects actually were successful and were adopted later. IIoT 2.0 will be focused on the user, the operator, and will help to help the operator to make decisions more easy. So, what's the link to asset monitoring? Well, there's a shift ongoing in the industry, and there's a new norm developed. And the new norm is going towards, it's going from inefficient, infrequent, manual inspections to automated sensor monitoring, and is as I already said, focused on the operator. When you look here, Steve this morning mentioned in his keynote speak, he presented this app where users can look at the emissions of their car, and you can get the information directly without going to an inspection place. This will clearly happen also here in the industrial world. We will not have operators going to data, the data will go to the operators. The subtitle of this presentation is small data, big insight. It's not big data, big insights. The industry is focusing on what matters, and it's not that we want to monitor everything. We only monitor what really matters. With better data, you will be going away from gut feel decisions, going to data-driven decisions. And then with more sensors being installed, you will have less people in the plant, and this will increase safety. And of course, when they are not going around taking measurements, they can be focused on what really matters, and this will improve efficiency. So let's go a little bit further into the details when it comes to rotating equipment. So regarding asset monitoring, so we're talking about monitoring rotating equipment and fixed equipment. What we currently have is, when you look at those more or less silos, rotating equipment and fixed equipment, those are fragmented solutions that usually tailor to rotating equipment or fixed equipment. There's inadequate coverage in time as well as in space. There is limited confidence in the measurement results. And when you look at analysis, they're very often delayed. So inspectors take data, they walk back to the office, they start the software in order to extract the data from the portable instrumentation. Then they have to export it and bring it to the database where it is usually analyzed. So analysis is usually delayed. And when it comes to the analysis, you will see a high variation dependent on the experience of the inspector. This will, of course, change, but going towards IIoT 2.0, you will see that we will get towards intelligent coverage in space and time, meaning we monitor where it matters and when it matters. Sensors will be more accurate than they were before. And insights can be, of course, extracted directly when you have real-time data. And decisions will be made based on data and not dependent on the inspector's experience. The real potential is in those overlaps, actually. When you're going and correlating asset data with process data in a quantifiable way. So the new potential is in correlating. You will have higher data quality, you will have higher confidence in measurements, and you will minimize the scope on what really matters. This will help you to improve the situation in those silos, let's call it silos, fixed equipment and rotating equipment. Maintenance and lifecycle costs will be reduced. But then you tap into the real potential, which is the overlap areas, where you can then improve operations reliability and efficiency if you're able to correlate. So how do we get there? Well, first you need to have innovative sensors. Even the sensors which are currently out there can be improved when it comes to accuracy. And we did this. You will see here some examples from corrosion monitoring and condition monitoring. Those sensors need to be very durable and reliable over years. You cannot have sensors you cannot use sensors for IIoT 2.0, which will last maybe 1 or 2 years. Those sensors need to be in the place for 5 to 10 years, and they need to still function at the time. Placement needs to be optimized. There's no way that you install sensors everywhere. This initial IoT concept of putting sensors everywhere is obsolete. There is a way to optimize the number of sensors. And then when you have sensors in the field, you don't want to have people walking up to maintain the sensor systems. Calibration needs to happen in an automatic fashion. That needs to be integrated. So then you collect data and you bring it to your database, and you have your software platform. And then usually you have your analytics going over it. And when it comes to the measurements, you're not usually analyzing your measurements directly. You will usually go and derive additional parameters out of it. So when it comes to corrosion monitoring, you're not necessarily analyzing thickness. You're looking at corrosion rates. You're looking at remaining lives, and that's what the operators use. So you need to be able to provide that. When it comes to vibration monitoring, the analysts look at vibration levels, but they also look at the spectrum which is derived out of the data in order to understand what is actually the root cause of the issue. When it comes to that, you don't want to add additional complexity. You need to be able to provide failure modes so that the analyst can easily decide what needs to be done. So you bring them into a situation where you have unambiguous decisions, data-driven decisions. We talked about tapping into the operational efficiency and reliability. this is absolutely the next step. You need to be able to quantify relations. This allows you to understand the whole correlation in a better way and allows you to do an analysis in a multi-dimensional fashion. You're looking at several parameters at the same time, not just at one. And this will allow you to move from running until failure over predicting when a failure will happen towards maximizing operations efficiency and reliability. So here are some examples. When it comes to corrosion monitoring, inspectors usually predetermine what's called thickness monitoring locations, TMLs. And if you look at a typical refinery, you will have a couple of 100,000 of TMLs. The minority is actually of high risk and really of high interest, maybe maximum 5%. 95% of all TMLs are what's called low risk TMLs. Usually nothing happens there. So what is the right approach to this? Well, for the critical TMLs, you will provide, or we will provide, like sensor systems, which will provide accurate measurements. And that allows to reduce risk and reduce cost and increase safety. For the low risk TMLs, there's a different solution which we developed, and that's Tml optimization. Usually, what when you look at manual inspection data and you look at low confidence the operators have in the measurement results, they're trying to compensate with even more TMLs or even more inaccurate data. So the goal here is actually to minimize the number of TMLs to an optimal number. And you can do this with like Tml optimization. We talked about accurate data and high precision. So here's an example of, again, from corrosion monitoring, a comparison of manual inspections and sensor monitoring. In the upper panel, you can see typical results from manual corrosion monitoring. So on the x-axis, you have time, around about 25 years of time. On the y-axis, you have thickness, add one specific TML. So what very often happens is shown here. Those blue points, they indicate measurements. So you start at some level, then a couple of years later, you take the next measurement and it goes down. That's what you expect. But then it goes up again. It stays there, then sharply drops and then goes back up. So what do you do with this? There could be two ways. So one inspector would potentially say, well, I have two outliers here. So this is active corrosion ongoing. But another inspector could come and say, well, I'm not trusting this one here. So most likely nothing happens and there's no corrosion ongoing. Well, that's decision making based on gut feel because you don't have accurate data. In the lower panel here, you can see a field example, where we had installed sensors. And you can see here that initially you have like a certain corrosion rate ongoing here. There's very low variation, and within like 2 weeks, we were able to determine the corrosion rate. Then there was like a gap here. That's when some repair work was done in the refinery on that unit. And then we continued monitoring. You can see here that the corrosion rate is much higher, much steeper. And the operators found out that the corrosion inhibitor pump was not working. So you can directly see the impact of when equipment is not working well, and you can see that relatively quickly within like 1 or 2 weeks. You wouldn't be able to see that when you have this kind of data. And that's actually what the operators confirmed. With manual inspections, we most likely wouldn't have seen this. So it allowed them to correct and work on the inhibitor pump, and then as soon as it started again, the corrosion rate flattens. Here's an example when it comes to TML optimization. This is a circuit. You can picture like a pipe string, and you have 74 TMLs on those pipes, on that pipe string. You can see here number 1 and number 2, they have different thickness, and then you have like this long section here. They're all more or less on the same nominal thickness. 74 TMLs on this pipe string. After we analyzed the data, we were able to reduce the number of TMLs to 3. Those 2, and then 1 for this whole section. There was only 1 TML necessary. Everything else was redundant information, which was not necessary and didn't play any role. That's a reduction of 96%. That's direct inspection cost reduction. So the key is in the future to be able to improve rotating equipment monitoring and fixed equipment monitoring in those silos, but also to tap into those overlapping areas with the process so that you can improve operations reliability and operations efficiency, while at the same time also safety is improved. So think IoT 2.0, stop by at our booth, you're welcome. Happy to discuss what we have. Any questions? Yes, no?
I like it.
Well, thank you.
Thank you.
Thank you. Nice.
Is this something we're using for our reliability group?
Yeah, so Alex has applications on it for vibration. Yeah, so they're using on both sides on fixed and.
Okay. Yeah, because I was thinking, because I know they're trying to put sensors and all those fun vibrations, but this, I mean.
Yeah, I think they're trying to help.
Yeah.
Yeah, he's at Corpus Christi.
Okay. So we're using sensors at Corpus Christi. We just installed like about 50 on the LP unit in order to support the whole eye software evaluation, which is supposed to predict.
Yeah, that's what I was thinking, that, I mean, that for this, it can easily predict when the thickness of maybe the pipe or something wrong with their pump. They can use this to predict it, and they can go in there, make repairs before the pumps or everything goes in.
And the other thing, kind of like where they're doing steam traps, some of that, I mean, that's part of the thing is, you don't have to put a sensor on every single one, right? It's really looking at, if I know what's going on in this one, and this one, does that really tell me what's going on in these other 3 anyway? Right. So can you get the data you need to analyze the actionable without, censoring nothing?
I like it. I like it. Hopefully, this guy's buying into it as well.
Yeah, I'm with you.
All right.
Yes, competition.
Yeah. All right, thank you.
Yeah.
Yes, sir.
Barnett was supposed to come.
Oh.
She says, I'm just going to the restaurant, be right back.
Yeah.
Yeah, here's my phone number, see.
I'm like, where is she? So I'm gonna say, man. Sasha was like, worried, like, where were you?
Yeah, they give away free laptops.
Wow. Had a door prize. Yeah.
Yeah, and only the competition shows up.
I mean,
And he's not
we're here.
even, that guy, Ed, he works for Marcella, he's not, he does process safety stuff. He doesn't do.
He was taking notes.
Yeah, just, well, I mean, we're out doing off-road research and doing it, so.
Right.
so-
Yeah, they have nothing. That's what we're finding out.
Well, that's my.
Well, I
that's
forgot
my-
to tell you.
That's why you're taking notes, so he will have something by next year.
No, I was telling.
It'll be IoT 3.0.
I was telling Tim that all the stuff that we saw yesterday, all that stuff's old. Emerson's had that forever. They just package it in an IoT, but they've always had wireless. They've always had wireless corrosion. It was all part of their plant web thing, right? It wasn't initially, it was more, they
Well,
would
they both
use.
thermostats to have those corrosion sensors, which mean,
Right.
non-intrusive corrosions.
Right. And they had it, but it was really more geared towards, working with their DCS system. So it wasn't really internet. It would use like foundation field bus or something like that as a protocol. And as all the internet stuff came, and I've been telling them for a long time, you guys gotta do more stuff on the internet. Oh, we can't. Their initial thought was like, there's no way we'd ever do the internet. I said, why? He says, well, because of the IT OT thing. And if OT, with IT get in there, it's nothing but a shit on, right?
Right.
Well, the market dictated otherwise, and then they started scrambling, and they said, holy shit, this internet thing's taking off. And then they started jumping on, but all this plant web stuff, that's been around since early 2008. Right? It's nothing new. Now it's plant web or digital, right? It's because when you think about it, the DCS system, if you take away the internet, I mean, really that's kind of how it works, right? It's sensors, it's all, they have wireless way, so I mean, but it was enclosed. They weren't using the internet as their standard protocol. They were using foundation field bus and those type of things, process controls.
Right.
But then they realized that's all. I mean, in fact, Emerson was instrumental in actually coming up with foundation. So I thought that was going to be the standard protocol. It never really took off. More in Europe, actually. So yeah, I don't think, someone asked the question, like, how do you decide where you put these sensors? Oh, you just ask the client, they should know all that. Okay. No clue about optimization.
But that's like the leak cost database that currently everybody pretty much uses. It was web app, web app, it was, on your PC kind of thing, on this, there's on our server base. And, like to access it, I had to go on VPN and then Citrix to get to this thing. And, one of our IT folks, Rajni, she called back up and she was like, you're not going to support Citrix anymore. We're going to get rid of that. You need to be web-based. No, nobody wants that. And then like a year later, she's like, if you guys don't move, we're going to move to go on your competitors. It is. So we better start working on it. So then they rolled it out. Okay, yeah, and they changed its name. It's not because it's Sky Bridge. It's got to go. It's the same tables, it's the same data.
Sure.
It's just
On the internet,
there. And
on the
then,
cloud.
and now they're like happy now they're telling us, yeah, we're black. But in the end, it's the same table, same relationship, relational database. It's just where you get to the data, how you get.
I think it was ExxonMobil, the big client of Emerson. They were the ones that put the gun to Emerson's head. They said, look, here's the issue. You guys, we have a DCS system that's client server based. Every 5 to 7 years, you force us to pay $1 million to upgrade. So well, here's what we're going to do. We're going to take all that data, we're going to put it in the cloud. And we're going to ask you to get to the data in the cloud.
Yeah.
Fucking Emerson. How are we going to do it? And we got more serious on doing the internet. But, and I'm not quite sure they're still there yet. I think most of Delta V still doing client servers. So, pretty easy. I don't think the Honeywells and the Emersons of the world are big competition. I'd be more worried about someone we don't know about that might tweak it.
So what did you think about the keynote speeches this morning?
Well, you know, what worried me was what the lawyers said. I mean, I found that more interesting than.
Well, it said the storm is coming, it's not here yet, yeah.
Well, here's my takeaway. Give you an example. One is greenhouse gases is all. And I feel that it wouldn't surprise me in 2 to 3 years that greenhouse gases don't have the emphasis that like the Biden administration is trying to put on it, right? So that's one. But the thing that worried me the most was how things haven't been decided yet to this point. We don't even know who the real people in there. And then the other thing was this whole government approach. I mean, you want to scare me? Get the whole government involved in the decision, right? And so my concern was, is that why it's been taking so long for the EPA to sign off on this?
I mean, part of it, under the last administration, we've been working, we had our contacts, we were working heavily. Once it switched over, yeah, it started slowing down a little bit, but the thing about this one is it still checks all the blocks for them, right?
Yeah, I think it
It
does.
goes from, calendar based to continuous based. It's got the data, it's got the measurements, it's got all the pieces they need. It's just like it never moving, they're like, oh, well, we don't want to make you, it was like, we don't want to accept this at the end because then they'll suspect it, and as soon as we switch administration, so just try to go back and overturn it, right? Just because they do, you did
It's
it.
been 6 months.
Yeah.
So it should be.
And then but it's just the way it goes, right? Like, we got it all agreed to, send it to the lawyer, we're giving them 2 weeks.
But this
At
just,
the end of that 2 weeks, they only had some minor changes, but they want these other 2 lawyers to guess a little bit more. And then, I got a phone call with them tomorrow, they're probably gonna say, yeah, with COVID slowing down, we got it, so it's just they don't have the
urgency.
yeah, I mean, it doesn't,
Well,
they're moving at what they think is a good pace, but for us, we're like, we spent this 18 months ago, come on.
Well, the good news, the other thing is that environmental people have a job forever. That was another job security seminar, that webinar was like, oh my gosh.
Well, I mean,
It's
so,
been added
so if
emissions
you-
credit. Oh
so I
my
mean, you
God.
know my background, right? So as a chemical engineer first, wanted to fly, got laid off after 9/11.
Oh, you got laid off?
Yeah, I was furloughed. Yeah, so-
Why?
Well, because like American Airlines at the time had 12,000 pilots. Post 9/11, when they started shutting down the travel, we ended up furloughing the bottom fourth of that seniority. So, the last 3,000 guys that show up on the property were gone.
You were one of them?
Yeah, but so, like, crap, what are we gonna do now? And we were living in Houston, and my wife's like, there's plenty of air work here, so I want you, update. So that's what I did. I went to SMU, got a master's in environmental engineering.
Why that?
Started doing the environmental engineering, just because there was just like this, right? The whole job security, there's a ton of work. Houston, all the industry was, so I was doing air permitting, air compliance, LDAR, you know, job security.
Oh, that's interesting. Yeah, it's funny, my brother was a pilot, and I'm sure he didn't have the same level of seniority. I'm surprised he didn't get that.
Which company was it?
He was with was it still Northwest at the time?
Oh, yeah, or actually, then it might have been Northwest Delta combined, yeah.
Yeah, so I can't remember if it was.
I mean, I had a lot of friends that got laid off, but, you know, that's the thing, he probably brought his seniority in.
But he never did military, and I don't know how long he'd been flying.
See, that's the thing, that's what's weird about the airline, when you come in, it doesn't matter how much experience you have, how old you are, or whatever, it's the order you get hired on that, you know, is where you are in the seniority list, and you never move up or down. Like when I got hired at American, back then, you could not carry passengers for hire after your 60th birthday, so like the day I showed up, they're like, here's a seniority list above you, here's everybody's birthday. So if you stay healthy on your last day, you know, when you're 60 years old, you'll be the 4th senior pilot. You know, there are 2 guys that got in that are younger than you, that are on, you know. So I mean, it's that kind of, so like guys that I worked for in the Navy, I got out for 12 years, you know, that were my bosses, but they stayed 20. Then when they came in, they were junior in the airlines. They had more senior, I mean, they had more flight hours, they had more. It's just the way the union is set up.
Yeah,
And then you bid what airplane you fly, what schedule you get, all that's
so
basically.
he started off on, he just made captain about 4 or 5 years ago. He was a
It's been pretty cheap.
Yeah, he was co-pilot for the longest time on 747, then he moved over to captain on 757.
Oh, so see, he stayed in the right seat a long time. So what happens is, you know, when you first get there, I mean, you're always gonna be so junior, you're a co-pilot, right? You're in the right seat. Depends on the airlines and what's going on, but it typically takes about 8 to 10 years to get enough seniority to be the most junior pilot captain on the very smallest airplane. But some guys want to get there as fast as they can. Get the right seat, don't be less, they won't be charged, won't get a little bump. Some guys would rather sit in the right seat and they get more and more and more senior in the right seat. So even though they could be captain, I'll stay here and I will not work any weekends, any holidays.
Yeah, that's what he did. He
Yeah.
was he did the on-call for a while.
Oh, yeah. And
This guy, I was in Hawaii for 3 weeks visiting, he didn't work a day.
Yeah.
He was at the beach with me and
Yeah.
all that. I was like,
yeah,
How
so
much you
some
getting?
guys, some guys go for the money and power, some guys go for the lifestyle. Because what happens, if you happen to be the most senior guy that's in, let's say, the right seat of 747, there might be a guy over here that's captain that actually is junior to you technically.
yeah, maybe that's what
But when
happened.
it comes to the bid, if you're the senior guy and the schedules, you bid his schedule, right? If he's only got to let it go. That's the schedule I want, I'll bid that one. The guy that's number 2 has got to bid at least 2 schedules, right? I'll bid this one, but in case the other guy wants the same one, I'll bid this. You know, you're down here, you're number 100, you're like, crap, yeah, it looks like I'll be, you know, flying on
Flying to Des Moines.
Thanksgiving, yeah.
Flying to Des Moines on Thanksgiving.
Exactly.
On the whatever.
So it's just kind of the way it works.
So yeah, he was in 747s for a long time, and then.
And see, the bigger the plane, right, you know, my theory is the more people you can kill, the more money, right? So the bigger the plane, more responsibility.
747s doing a lot of flights to Tokyo and.
Yeah, see, that's the other advantage. Guys get senior, you fly those because the flights are so long.
Yeah.
You know, you might only fly 8 days a month.
Yeah.
You've got your full schedule, where if you're on the smallest plane, you're on 737 and you're doing Chicago, Des Moines, and Dallas, you know, you're bouncing around, you're only getting a few hours a day. Then you end up, you know, I mean, still, like when I was there, the most junior schedule, you still got 10 days off. And then 10 or 11 days off. But the senior guys, yeah.
Yeah, it was amazing. I just asked one
It's
day,
just a weird business.
after about 10 days, I said, do you ever work? He says, I'm working now. I said, what do you mean? He said, I'm on call. I have to check every day and I got a pager.
Yeah, but,
So
yeah.
he said, hey, I could get paged tomorrow at 3 in the afternoon. I got 2 hours to get.
They'll start
home."
in 2 hours. You gotta be at the airport in your uniform, ready to go.
And so he lived on the Big Island.
Yeah.
But it's only a 40-minute flight.
Yeah.
I guess he can jump on
Yeah,
any
you can,
plane.
yeah, you can
So
come see, yeah.
he can get on a United flight or Hawaiian.
I mean, it's a
They
cool
would get him
lifestyle.
over there.
So I got furloughed, I told you went to school, I got hired by Dow, and like the first day I showed up at Dow, I got my recall, they called and said, okay, we're ready for you to come back, and so okay, I'll pass on it. And I just had a new son born and all that, so, just kind of, I kept passing, because they start with the most senior, you ready to come back? No, I'll pass, okay, the next guy, you ready to come back? Okay, come on. As they need pilots, they bring them back, they work all the way through the bottom,
And then they go back up.
then they go back in reverse order, which is you either come to work or you're off the list. And, come work, you're off the list. Oh, we probably should stop the recording, sorry.
It's okay, they'll edit it,
Okay.
yeah.
You'll edit the dead space out,
Yeah,
or me talking about my life and everything, you'll edit that out. Okay.
or I mean, we can leave it in there.
So,
It'll be boring to fall asleep.
yeah, so it was interesting.